Assalamu alaikum. The main purpose of this video is to introduce a website called Phet. First, the Phet website it was an acronym. When they first developed the website, it was an acronym. It stands for Physics Education Technology, because at the very beginning they were dedicated only for physics simulations. Now they have a very wide range from math to chemistry and physics, and also biology simulations. It was founded by a Nobel laureate called Carl Wieman. He's an American physicist, and he decided after winning the Nobel Prize to found this project. It's a non-profitable project, so every one of us can donate. Actually, there is a huge range of sponsors. For example, that you will find King Saud University, you will find University of Colorado, so on and so forth. So it's very well known and very common that you will find reputable institutions like McGraw-Hill or Brain Pop funding this kind of project. I decided to showcase a different simulation other than the one we explained during the course. So it's more beneficial or meaningful to be introduced to two different simulations. I decided to choose this simulation. It's about density, so it can be tailored to middle school, high school, or even elementary students. Once you click on the simulation, you will find they have two versions, one with a flash player and one with HTML, so you can play it on the browser itself, or you can download it if you have a flash player and play it on your PC or laptop. Once you click on the simulation, it will open up a new page, which is this page. You will attempt to view the simulation anyway, then you will press and click to enable Adobe Flash Player. You will have a pop-up window that is asking you to allow Flash Player to act on the browser. After allowing the Flash Player, the simulation will load. I will wait till it loads. Okay, here we are. This is the first window that will appear to students or to the teachers once they start the simulation. You have different scenarios. You can assume that you have the same mass or the same volume of the blocks. So it's very straightforward. If you are teaching students the relationship between mass, volume, and density equal mass over volume, you can easily explain it, or you can easily demonstrate the idea by having this same volume simulation. You can click on the boxes, drag them into the water. You can check the volume to subtract the volume before and after. Now you have the volume and you have the mass. You can easily calculate the density. You can also repeat the same experiment but using the same density, which is unrealistic. But it's good to have such probability. Then the last part, which is I think the most fun part for the student, is the mystery boxes. You have mystery boxes and they have a reference guide, and every student should calculate the density and check them against the reference guide and tell you the identity of the material itself based on the density. Okay, how can you use this simulation? For example, you can use it as a demonstration inside the class, and you can use it as a task, investigation task, or as an alternative for having this experiment in the lab, especially during this online education phase. So, for example, I have already made a demo for such a task. It's a criterion C for me, so it's an implementation of a design, implementation of an experiment. The purpose of the experiment, I provide my students with the link, and then I will introduce the task itself, which is you are required to determine the relationship between mass and volume and mass and density. Then you will try to identify the unknown object, which is A, B, C, and D, the mystery part in the simulation. Then I will clarify the task into bullet points. I will ask the students to explore the simulation at first, then choose same volume and record mass and calculate density. Same goes for the same density part. They will record the mass and calculate the volume. Then I will ask them to draw graphs, the independent and dependent variable, while mentioning طبعا a control variable. Then I will try to explain the trends and tell me the scientific reason behind why the relationship is directly proportional between, for example, mass and volume when you have same density. So this is for me a big task. It will take, for example, 1 week. Then they will hand out the first draft. I will give them a feedback. Then they will hand me out, hand me in the final draft. So this is one way to implement, or one way to use the Phet simulation. I use it sometimes as demonstration. Some tasks is very straightforward. There is no need to waste time playing around the simulation. طب why do we use simulation? Because sometimes the material itself are not available in our schools, especially nowadays, because يعني, there's a problem in importing and exporting chemicals, importing exporting material. So it's very straightforward and very easy to use a simulation that can simulate the real scenario inside the lab, especially when it comes to chemistry. You will find chemistry resources including acid-base reactions. So this is the range of the simulation: physics, chemistry, math, earth science, biology. You can donate, and please consider this if you are using Phet simulation on a regular basis. Consider donating even if a small amount. Um, that's all. Please, and feel free to ask me if you need any resources. The Phet simulation is only one platform for this. There's other resources, other platforms, and you can easily find here in Phet simulation already lesson plans. Teachers submitted lesson plans like the one I did. I can submit it on phet.com as a contribution, a free contribution, so other teachers can use it in their classroom. They can tailor it to the classroom. They can tailor it to the curriculum. So it's a collaborative process. You will find many educators putting their work, sometimes with model answers, sometimes with يعني, especially no model answers. So give it a try, and feel free to ask me if you have any other questions. Thank you so much.